Hello everyone and welcome back. I'm Hellcat Diva and today I have a Figure It Out episode. In my last video I shared my first experience on a road course. A few people approached me that day to ask if my car was spinning out in the curves, and of course, as you saw in the video, it did not. Quite frankly, it was my first time. I wasn't pushing it that hard, and I did a pretty good job of identifying the apex cones and staying on the drive line. But I will be honest, it was at the back of my mind a few times, especially when approaching the end of the straightaway and making that sharp right turn in turn one. So I thought, this is a teachable moment. It would be a great idea to take a look at turn one and calculate the minimum coefficient of friction required between my tires and the road, of course, based on the average speed I took through that turn throughout track day. And looking back at all the footage, I was taking that turn at about 36 miles per hour. So today's Figure It Out problem is, I am traveling at 36 miles per hour around turn one of the Speed Vegas track. What coefficient of static friction is required at this speed between the tires and road to prevent skidding if the radius of turn one is estimated to be 80 feet? Now, I estimated 80 feet by looking at the track in satellite mode in Google Maps, making a circle and estimating that circle's radius using the Google Maps legend. So it's not quite a wag, but it's not quite accurate, so it truly is an estimate. So whenever you are doing physics problems, the first thing you need to do is write down everything you know and also convert everything to the same units. So that will save time later, especially when you're taking a test or in a crunch when you're doing your homework. So knowing I had the radius in feet, I converted my speed from miles per hour to feet per second. And we should always indicate what we are solving for. And in this problem, that is mu sub s, the coefficient of static friction. And as a side note, if this was a problem to solve for kinetic friction, we would call it mu sub k. The next thing we want to do is consider what type of problem this is. Now, for all of you engineering majors, problems like this will appear in your first semester of physics in the chapter for centripetal force. Most of the time, the coefficient of friction is given as a variable in your homework, so I try to change things up a little bit. In this problem, the normal force times the coefficient of friction is equal to the centripetal force. And the equation for that is mv squared over r, the mass times the velocity squared over the radius. So this is a good time to pause this video. If you want to solve it on your own first, then unpause it and solve it along with me. So another thing I like to do is solve for that one thing that we're trying to find. So before I include any values for all of the known variables, I took the time to solve for the coefficient of friction. First, I converted the normal force, which is the force that is countering the weight of the Hellcat, which is the mass of the Hellcat times the acceleration due to gravity. So now you're probably thinking, well, you didn't tell me what the mass of the Hellcat is, but don't fear, here's why we won't need it. If you notice, the mass is on both sides of the equation, so they cancel one another out, leaving us with the coefficient of friction times the acceleration due to gravity equal to the velocity squared over the radius. Isolating the coefficient of friction on one side and moving gravity over to the other, we have finally solved for mu. Now we can enter all of our values. So for the velocity squared, we have 52.8 squared, which is 2787.84 feet squared per second squared over the acceleration due to gravity, which is 32.17 feet per second squared times 80 feet. That also leaves us with feet squared per second squared, so it cancels all of the units out, which should always happen if you're solving for a coefficient because they have no units. Finally, we have the solution for the coefficient of friction, which is 1.08. So, how did you do? Did you get the same thing that I did? Let me know in the comments. That's it for today's Figure It Out. But before you go, if you would like to take my Hellcat journey with me by subscribing to my channel, I would truly appreciate it. And I'll see you in the next video.